Okay, so we're going to do the first part of section 1.6 here. So we get 1.6. Whoops, hang on. I think let me clear that out so we get a clean board here. So we get a 1.6 part 1. We're going to do a couple examples from the book. So first example wants us to look at 3x minus 1 over 3. So this is part A. 3x minus 1 over 3 minus 2x over x minus 1. And then that's going to equal just x. So with these problems, there's two things we got to do before we get going on them. We need to list something called restrictions, which these are x values that cause division by 0. So if I let x right here equal 1, 1 minus 1 causes division by 0 in that term. So my restriction is x cannot equal 1 for this problem. Next, I need to find the LCD, and that's going to be the smallest things that all the denominators divide evenly into. So my LCD needs to have something that 3 divides into and x minus 1 divides into. So we'll use a 3 times x minus 1. Then what we do with that LCD is we're going to multiply each of the terms here in our problem, but in the top, by 3 times x minus 1. What happens is the denominator 3 cancels. That'll leave me with a 3x minus 1 times an x minus 1. In this term, the x minus 1's cancel. That'll leave me a negative 2x times 3, which would be a negative 6x. And out here at the end, I have 3 times x times an x minus 1. Nothing cancels, so I just get my expression like that. But the nice thing about this is I don't have fractions anymore. So I'm going to FOIL out the first term. I'll get 3x squared minus 3x minus x plus 1. Still have a minus 6x. Out here I'll distribute. I'll get a 3x squared minus 3x. I need to move these terms across the equal sign so I can start gathering stuff up. So I'll subtract the 3x squared across. And it cancels out on the right-hand side. And luckily it cancels out over here as well, so we don't need to worry about it. We add the 3x on over. Cancels here and cancels here as well. So my leftovers are negative x plus 1 minus 6x equals 0. Well, the 1 doesn't have an x in it, so I'm going to slide the 1 over here as a negative 1. Negative x minus 6x is negative 7x. If I want to get the x by itself, I divide the negative 7 across. Negative over negative is positive, so I get 1/7 for my x. So I need to make sure that 1/7 isn't a restriction. My restriction was 1. 1/7 is not 1. So this works. This is a solution. So that solves my problem there for part A. So for part B, they give us this other expression they want us to solve, which is x over x minus 2 equals 2 over x minus 2 plus 2. So again, we got to find our restriction, which in this case, 2 causes division by 0, and 2 causes division by 0 here. So our restrictions are x cannot equal 2. For our LCD, if I have an x minus 2, x minus 2 divides into x minus 2, x minus 2 divides into x minus 2. So this is big enough. I don't need anything larger than just x minus 2. So I'm going to multiply the tops of these terms by x minus 2. Guess I probably should put them in parentheses. And what happens here is the x minus 2's cancel. I get left with the x. Here the x minus 2's cancel. I get left with the 2. Out here nothing canceled, so I get left with 2 times x minus 2. So I let the 2 distribute here. I get x equals 2 plus 2x minus 4. I'm going to subtract the 2x across to get all my x's gathered up over on that side. So I get a negative x equals 2 minus 4 is a negative 2. So I divide by negative 1, and I'll get positive x is positive 2. We check that against the restrictions. The restriction said x couldn't equal 2. Well, we got x equals 2 as our solution, so that doesn't actually work. And this is a no solution for our answer. Because if there was a solution, it would be x equals 2, but x equals 2 causes division by 0, so it doesn't actually work. So moving along to example 2. Part A, we got the expression 3x plus 2 over x minus 2 plus a 1 over an x equals a negative 2 over x squared minus 2x. So I have to go through and I have to factor the bottom part here where it says x squared minus 2x. So I'm going to do that before I get finding restrictions in LCDs. I need to factor that to see what do I actually have down in the bottom of this. I can factor out an x, so I get an x times an x minus 2. Okay, so on this one, let's list our restrictions in our LCD. Restriction, well, 2 will cause division by 0 in this first term. 2 will cause division by 0, or sorry, 0 will cause division by 0 in the middle term. 0 causes division in this term, and 2 causes division in that term. So we get x cannot equal 0 or 2. So 0 and 2 are both no good. For my LCD, we're going to look at, we need something that has both an x and an x minus 2. So we'll do x times x minus 2. And then that's what we're going to multiply the tops of these by. So x times x minus 2, x times x minus 2, x, oops. So multiply out there, x times x minus 2. So in the first term, the x minus 2 cancels with the x minus 2. We get a 3x plus 2 times a leftover x. In this middle term, the x cancels. We get left with just an x minus 2. That equals, in the last term, the x cancels, the x minus 2's cancel, and we get a negative 2. So I'm going to add the 2 across to try to get one side compared to 0. Actually, it cancels here as well. I distribute the terms here, so I get 3x squared plus 2x plus an x equals 0. 2x plus x is 3x, so I get 3x squared plus 3x is 0. I can factor out a 3x, so I get a 3x times an x plus 1 is 0. This will say 3x is 0, which says x itself is 0, might be a solution, or x plus 1 is 0, which says x equals negative 1 might be a solution because the positive 1 scoots on over. So these are our two possible answers. We check them against the restrictions. 0 and 2 can't be solutions. So our possible solution of 0 is out. But negative 1, that's not 0 or 2. So this one we keep, and this is our solution to that problem. So we say, all right, that one's okay. Okay. So the next example is part B. So we got... For part B, we have negative 4x over a x minus 1 plus a 4 over an x plus 1 equals a negative 8 over an x squared minus 1. So I'm going to rewrite this. I need to factor the denominator of that third term. And let's see here. So factor the denominator of that third term. So that's going to be an x minus 1 times an x plus 1, because that's a difference of squares. So for my restriction, I get x cannot equal 1 or negative 1. For the LCD, I need something that both x minus 1 and x plus 1 can divide into. So I'm going to get their product x minus 1 times x plus 1 for the LCD. And then I'm going to go through and multiply the tops of these by x minus 1 times x plus 1, x minus 1 times x plus 1, and out here times x minus 1 times x plus 1. So I've multiplied all the tops there by those. The x minus 1's cancel. We'll be left with negative 4x times an x plus 1. Out here, the x plus 1's cancel. We'll be left with a positive 4 times an x minus 1. Out here, the minus 1's as well as the plus 1's cancel, so we're left with a negative 8. So what we got to do here is distribute the negative 4x, and here we got to distribute the positive 4. So we'll get negative 4x squared minus a 4x plus a 4x minus a 4 equals negative 8. So what I need to do is I need to move everything over to one side of the equation, so I'll add 8 to both sides. That'll let the 8 cancel out, and we'll get a 0 over here. I'll have negative 4x squareds minus 4x plus 4x actually add up to nothing. Negative 4 plus 8's plus 4, so I only have this here. Okay, I'm going to scoot the negative x squared term across the equals as a positive 4x squared. So we'll have 4 equals 4x squared. We'll divide both sides by 4. That'll say 1 is x squared. To get rid of the square, we'll take plus minus square root of both sides. And that'll cancel out the square in the square root. So we'll get x is plus minus square root of 1, which square root of 1 is 1, so we get x is plus minus 1. We checked out our restriction. Our restriction, x can't be 1 or negative 1, so plus minus 1, both of them are no good. They are both restrictions. So this one ends up being no solution. So, okay. So for the next bit, we have a problem involving some, I guess, printers working on something, so we'll do that. This will be example 3 from the book. So we say one printer can do a job twice as fast as another. So one printer can do a job twice as fast as another. Okay. Working together, both printers can do the job in 2 hours. So working together, both printers can do a job, or can do the job in 2 hours. And we want to know, working alone, how long would it take each printer to do the job? So how long would it take for each printer to do the job alone? Okay. So we're going to look at time first, and we'll say, all right, let's just kind of compare times. So let's say we got the faster and the slower printer here. So if the faster printer takes time t to complete the job, the other printer works twice as long, so it would take time 2t. So if that's the time, the rate, if it takes t hours to do the job, the faster printer works at a rate of 1 over t. The slower printer will work at a rate of 1 over 2t. And this kind of makes sense because if t is 7, then the first hour the printer gets 1/7 done. The second hour gets 2/7 done. Then 3/7, 4/7, 5/7, 6/7 until the 7th hour it gets 7/7 done, which means it's 7/7 is 1, so it gets the job done once. So what we're going to do is we're going to say if we take the rate of the faster printer, we multiply it by the time the faster printer works for, which we said 2 hours. If they're both working together for 2 hours, they get the job done once. So we have 1 over time, that's the rate of the faster printer, times the 2 hours it works. That's how much of the job the faster printer completes. If we add to it the rate of the slower printer times the 2 hour it works, that will be the amount, I'll write that down here, amount of job done by the faster printer. It's its rate times the time it works for. And this over here would be the amount of the job done by the slower printer. So it's 1 over 2t for its rate, and it works for 2 hours. So if they do that, they get the job done once. So I'm going to algebraically simplify. We have a multiply by 2 and a divide by 2, and 2 times 1 over t. We get 2 over t plus 1 over t is 1. Which I could say 2 over t plus 1 over t, that would be 3 over t equals 1. We can multiply the t across, so we get 3 is t. So it would take 3 hours for the faster printer working alone to complete the job. So if it takes 3 hours for the faster printer to complete the job, and the slower printer takes twice as long, you can see, well, t is 3 for the faster. The slower printer will be 2 times 3, which will be 6. So 6 hours would be how long it would take if the slower printer tried to complete the job by itself. So that's that one. Then we have one final problem we're going to look at for this part, and then that'll be where we stopped in our lecture. So we'll get the rest of it put up there next week. So for this example 4 from our book, we have wanting to solve x minus the square root of 15 minus 2x equals 0. So if you want to solve something like this, the first step is you need to isolate the square root. So we need to isolate the square root term. So to do that, I need to move the square root term across the equals. So I'll get x equals square root of 15 minus 2x. Now that I got the square root term completely by itself, I can square both sides of the equation. Squaring will undo the square root, and I'll get x is 15 minus 2x. Sorry, x squared is 15 minus 2x. I'm going to push all these terms over here with the x squared. So I'll get x squared plus 2x minus 15 is 0. This will let me factor. So I'll get x and x. So I need two numbers to multiply together to be a negative 15, but add up to a positive 2. So that'll be a 5 and a 3, positive 5 and negative 3. So I'm going to use the zero factor property of x plus 5 times x minus 3 equals 0. It says x plus 5 is 0, or x minus 3 could equal 0. So to solve these, we'll just add subtract the 5 over, and on this one we'll add the 3 over. So we'll get x is negative 5, could be a solution, or x is positive 3 could also be a solution. With these square root types, we have to check our solution, and you have to check them in the original form before you squared the problem. Because when you square the problem, that's where you might have the possibility of bringing in your extraneous solution. So what we need to do is check the problem, check our solutions in this form here. So let me put negative 5 in for x. I'll do that in a different color. So we'll say, all right, negative 5 minus the square root of negative 5 times negative 2 is 10. 15 plus 10 is the square root of 25. This is going to equal, that's negative 5 minus 5 equals negative 10. It's supposed to be 0, so that doesn't work out. So x cannot equal negative 5. That doesn't get us where we want. For x equals 3, we're going to try that one. I guess different color. So we'll say All right, 3 minus the square root of, see, if I put 3 in here, 2 times 3 is 6, so that's 15 minus 6 is 9, so that's 3 minus square root of 9. Square root of 9 is 3, 3 minus 3 is 0. That is good, that's what we want. So x equals 3 solves that problem. So that is basically where we left off at lecture this week, so we're going to stop there, and we'll finish up the rest of section 1.6. We'll finish that up next week.